This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com.
What I want to turn to is discounting, compounding, interest, investment appraisal. So, several things which each of them individually, I think are easy enough. But because there are several different things, I've got 3 sheets here. So, let's get through them, then you can have a go at everything. First of all, on compounding, let's check the 2, be happy with the words and so on. If $1,000 is invested for 2 years at compound interest of 10% per year, what will the deposit have grown to by the end of the period? And remember what we mean by compound interest. With compound interest, it means the interest each year is added to the amount in the account. And so, in the second year, you'll be getting interest on a bigger amount. Are we understanding me here? You'll get interest on interest. And so, if they ask you to do this here, how much will it have grown to at the end of 2 years? Then although you can get the same answer several ways, and obviously the main thing is to get it right, I think the most efficient, the quickest, but be clear why, is we start off with 1,000. After 1 year, you'll add on interest of 10%, which obviously you can do in your head is an extra 100. You've got 1,100. More efficiently, to add on 1 year's interest at 10% multiplied by 1.10. That if you multiply by 1.1, surely you've got 1,000 plus 0.1 or 10%, 1,100. That the 0.1 there is because it's 10%. However, that's how much you'd have after 1 year, but we leave all the money in, all 1,100, for a second year, and in the second year the interest is 10% on the whole thing. I think you're all understanding me. So again, although you could do it writing them all down more efficiently, to add on another year's interest at 10% multiplied by 1.1 again, and so 1.1 squared. And therefore, the amount at the end of 2 years, if somebody would check me, I think it's grown to 1,210. Alright? Now is everybody clear, please? As I said before, since the computer doesn't care how you did it, by all means, if you want, write down that 1,000 after a year is 1,100. 1,100 plus interest is 1,210. That doesn't take long, but had it been 3 or 4 years, this approach is more efficient. And so just make sure you've got it. Could you do this for me, please? Suppose it was 500 invested for 4 years. The interest is 12% per annum. How much would it be at the end of 4 years? 4 years, not for years. For 4 years. I'll give everybody a chance. I'm sure you're right. But, the first number was certainly right. I didn't let you say the other numbers. Alright, does anybody want to give me a figure? Do you want to give me the full figure, Christina, there?
I got 786.7.
Yeah. But again, any way you like, but here when it's 4 years, I certainly think this is a lot quicker. to add on 12% each year, multiply by 1.12, 0.12 for 12%, multiply by 1.12 each year, here for 4 years, boom, boom. But again, make sure you can be efficient on your calculator. Incidentally, some of you have calculators that might do that immediately. Otherwise, I mean, too many people go 1.12 times 1.12 times 1.12, and then you think, oh shit, how many times have I done it? And you lose count. What I'm about to say doesn't work on every calculator, but it should on most. If you go 1.12, if you press times,
You could just press one time.
oh well, it depends on your calculator, but with mine I have to go the multiply sign twice, and then every time I press equals, it gives it squared, cubed, to the 4th. If I'm not making sense to me separately, but play with your calculator. Everybody's calculator works differently, obviously. Liga's works differently from mine, but, you know, especially I'd have done it for 12 years, to sit there multiplying 12 times, clearly, you'll forget where you're up to, and keep having to start all over again. Anyway, otherwise, we should be happy there. The second one, a similar sort of principle, but make sure you are happy with it. A bank gives simple interest of 12% a year, with interest credited to the account quarterly. They want to know what is the actual rate of interest per year. Well, simple interest is what we call it when we're ignoring this compounding, this interest on interest. Okay? So if it's simple interest of 12% per year, well, if it's ignoring all the compounding bit, how much is it every quarter? If you ignore interest on interest, if they're giving 12% a year, how much would it be every 3 months? Yes, no tricks. If it's simple interest, it would simply mean, if it's 12% a year, it's 1% a month. Or quarterly, it would be 3% every quarter. However, if they're charging or giving you, either way around, 3% every quarter, because of compounding, the actual rate of interest is actually going to be more than 12%. But here, I haven't told you how much we'd put on deposit, but whatever it was, were it 100 for instance, surely if it's 3% every quarter, by the end of a year, you multiply by 1.03 every 3 months. There are 4 3 months over a year. You'd multiply by 1.03 to the power 4. Do we agree? I want to know what rate of interest is that per year. Well, again, I don't care what the amount is, but if it were 100 again, and if they were just charging you sort of X% a year, after 1 year, you'd multiply by 1 plus R, where R is the interest per year. If it's 10% a year, you multiply by 1.1. If it's 20% a year, 1.2, and so on. Well, what is 1.03 to the power 4? Will you check me? I get 1.1255. And therefore, what is the rate of interest, the true rate of interest per year? 1 plus, well, it's 0.1255 or 12.55% per year. So that they can ask various ways round. But 3% every quarter compounded is the same as 12.55% every year. Again, if it's not clear, shout. By the time we finish these 3 sheets, there should be just about anything you can ask. Are we clear, or aren't we? Okay, well that was on interest. However, the next 2 sheets are on the discounting, where there is going to be more. So I might as well get rid of the whole lot at once. Sorry, did I give you one or not? Oh yes, sorry. Investment appraisal. Now again, forgive me. I spent quite a while last time going through all the logic behind it. Now's not the time to worry about the logic. If anybody's forgotten and is worried as we go through, speak to me separately. In the exam, it's got to be speed and just numbers. They test you on the arithmetic. They're not testing you on the reasons, even though I think you should remember why. But it tells us here we've got a project with the following cash flows. So we've done whatever forecasts we need. And this project, we expect to spend 75,000 now times 0. We expect to get cash back of 20,000 in 1 year, 30 in 2 years, 50 in 3. It says if the cost of capital, if the cost of money is 10%, what is the net present value? And as I say, without repeating all the reasoning behind it, basically what we're doing, we want the net cash flow. We've paid out 75, we get back 20, 30, 50, we get back 100. But because we're having to wait 1 year, 2 year, 3 year, effectively we remove the interest. Because the longer we wait, the more interest will be payable on any money we've borrowed. Well, again, in the exam, I'm afraid it just has to be automatic. They will ask you for a net present value. I'll need to write down the flows. 75, 20 in a year, 30 in 2 years, 50 in 3 years. The net present value, to remove the interest to get the equivalent amount now of the present values. We multiply in each case by the discount factor. We want the equivalent amount now. 75 now is 75 now, no problem. But when we come to 20 in a year, we need to remove interest. The equivalent amount now is going to be smaller. Well, if you remember, they give you present value tables. And all they'll be expecting is you can use them efficiently. I gave them yesterday. Has anybody not got the tables?
I have them in my car.
Oh dear. Well, that'll be a problem in the middle of the exam. I think I've got a spare one somewhere. You are very lucky. Now the only thing here is, I say, in the exam it's just got to be automatic. Be so careful. Remember, the problem in the exam is speed. Be so careful you use the right page. I'll remind you what the other page is separately. But for this sort of problem, you're using the one that's headed up present value table. Alright? Be terribly careful. I say that when you're rushing, it is so easy to pick the wrong tables and get a completely stupid figure. So are we all looking at the right table? Present value table? And here, the discount factors. We're doing, what was the rate of interest? 10%. The 10% column The rows are for 1 year, 2 year, 3 year, etc. So check you've found them, shout if not. But 1 year, 10%, you multiply by 0.909. 2 years, 10%, it's 0.826. 3 years, 0.751. Have we all found them? Hello? And remember, to get the present value, you multiply by the discount factor. And unless you are told differently, do things to the nearest dollar. So 20,000 times 0.909 is, bless you, 18,180. 30 times 0.826 is 24,780. 50 times 0.751. They all went exact, but if you do end up with cents, as I said, do it to the nearest dollar unless they say different. Clear? Remember, those individually are present values. If he did just say, what's the present value of 50,000 in 3 years? It's 37,550. However, when we're using it to decide on projects, we look at the net present value. And it means precisely what we said. What's the net total? 18,180, 24,780, 37,550 minus 75,000. Has anyone checked me? 5510? And although in the exam, probably they'll just want the total. Remember, the total could be positive, it could be negative. Here it's positive. You're all with me? You know, had the original cost been 85, it would have been negative. Well, just in case, he asks, remember the idea, if the project gives a positive net present value, it means it gives a cash surplus. If it's positive, you would accept the project, it's good. Had the answer been negative, it would mean after interest you lost cash, you would reject the project. Okay? So, there are things we need to carry on, but there has to be, well, I can't believe there'd be less than 2 certainly of doing the net present value. Are we all happy how we're using the tables? As long as you pick the right sheet, I really think there's no excuse, apart from, just silly mistakes. Okay, Akita? Sorry, no. I wasn't suggesting... All right, let's carry on, though, because there are 3 other things he could ask. Number 2, for the same question, it says, what's the payback period? Well, it's one of those things you either remember or you don't. Let's not waste time. The payback period is the number of years it takes, to get back the original investment. And, although it's implicit, in cash terms. Again, we look at cash flows. Be clear what I mean by the statement, but this investment, this project, cost me 75,000. And so, it's looking at the receipts, it's simply saying, how long does it take to get back 75,000? Clear? And so let's not waste time. For this question, after 1 year you've had 20. You agree? After 2 years, well, second year's another 30, so after 2 years you've had 50 in total? Everybody? You got 20 back in the first year, another 30 in the second, so after 2 years the total you've had back is 50. Hello? Are we there? What? Oh yes, I know. I'm sorry, I'm going to write the next bit down. But we had 50 after the end of 2 years. We've still not had enough, we need 75. In the third year you get another 50. So you've had a total of 100. Well, I hope to get 75. Two things. Are we clear that it's between 2 and 3 years? And how much? Well, after 2 years you've had 50. We need another 25,000 to get back the 75. How long will it take to get the other 25? Well, the third year gave us 50. It takes us 2.5 years. Now, sorry, you can get 2.5 almost in your head, if you understand. I don't want to confuse anybody. But are we all clear? It'll take 2 years to get back 50,000, yeah?
Why do we take these figures and not the present value figures?
Because we call that the discounted payback period. The payback period itself, you take the actual cash amounts. You with me? And so on that basis, are you happy what I've done there? Yeah? But yeah, be very careful. I'm coming to discounted payback period in a minute. But payback period itself, how many years to get back 75? Well, Irina's happy, but is everybody happy? Why? It's taking 2.5 years. Everybody? Okay, well, as I just said, do be careful, because he can ask either or both of payback period and discounted payback period. And obviously, be careful, don't give the right answer to the wrong one, if you understand me. The only problem with payback period is, of course, we have ignored the interest. Sorry, Laura?
No.
Yeah. The discounted payback period is exactly the same idea, but instead of using the actual cash flows, you do exactly the same thing, but on the present values. So you're paying out 75. How long does it take in present values to get back 75? Are we clear? Well, because it is exactly the same idea, can you do it? If you've already done it, be patient for a second. But how many years will it take on discounted figures to get back the 75? Alright, exactly the same idea, but that tiny bit more complicated, obviously. Anybody got a figure?
3 years and 2 months?
10 months. 10 months? Whatever. Let's check. And incidentally, as I'll explain as we go through, before you do it, always look at the choice of answers, because there are two ways they could expect you to write it. But what I mean is, in exactly the same way, after 1 year you've had 18,180, after 2 years 42, which isn't enough. We need 75. After 3 years 80, which is enough, so it's clearly between 2 and 3 years. How many is it going to be? 2 years plus. Well, how much do we need? After 2 years you've had 42,960. To get 75,000, the extra we need is what? I think we need an extra 32,040. How much in total do we get in the third year? We get 37,550. So it's that fraction of the third year. You agree? What I meant by saying there are two ways they can do it, or expect it, that actually comes to... Will somebody check me? I get 2.85 years. And probably the choices will be like that. 2.1 years, 2.8 years, and so on. So you are all clear how I got 2.85. Less likely, but possible. Christina, as somebody said, 2 years and on so many months. If it was like that, it's 2 years and... how many months? So with 12 months in a year, obviously. 0.85 of 12 to the nearest month is 10 months. Now the second one is less likely. But all I'm saying is, before you spend any time, look at the choices and know which one you're going for. Rather than do one and then have to convert it. However, nearly there for this sheet. But we are all happy about payback and discounted payback? Finally, on this one, for the same project, it wants to know what's the internal rate of return. And again, this will be asked, and almost certainly the way I've done it here. And so make sure you've got this, because if you have it, again, it's very, very easy. In part 1, before I go any further, because of written questions, can somebody remember what's the definition of the internal rate of return, or the IRR? Forget numbers, there could certainly be a written one here, statement 1. What's the definition of the internal rate of return? Oh, again, time goes so fast. For heaven's sake, learn it. The internal rate of return, it's the rate of interest at which the NPV is 0. Rate of interest at which NPV is 0. Because, of course, our project, we were told the rate of interest was 10%. We discounted and got plus 5,000. I hope, obviously, had we done it at a different percent, had you done it at 20%, I hope, clearly, two things. Number one, you'd have got a different net present value. Do you agree? And secondly, I hope sensibly, if the rate of interest were 20%, if money's more expensive, the net present value would be lower. You agree? What we're after by definition is what rate of interest would give us an answer of NPV 0. Clear? Well, the way always we do it in real life is you effectively try two rates of interest, and then using those two rates we approximate. Because of the time taken in the exam, what they'll do is what I've done here. Part 1 asked us to calculate at 10%. And at 10%, we worked out a net present value. I've wound forward. It was 55. Can somebody tell me?
5510.
Yeah? 5510. Note 4, for the same project, it says the net present value at 15% is minus 2060. We could calculate ourselves, obviously. Because of the tables, you could simply repeat exercise 1 at 15%. You're all agreeing with me? However, to get you to do 2 discountings in one question is virtually impossible. But do you all agree you would be capable of getting the 2060 yourself? Laura? Yes. However, with those 2 answers, we then estimate an NPV of 0. Would you all agree, since it was plus 5 minus 2, to get 0 must be somewhere between 10 and 15? Well, I said, well, none of you seem to remember, but I did say before there are several ways you can get the same answer. You can learn a formula, but I think that's dangerous. You're not given the formula. It's in the middle of an exam, you'll forget it. It's your choice. I still think my way is the same as the formula, but once you understand it, then I don't think there's so much a question of learning. All we do is this. We say between the 2, we've changed from 10 to 15, it's changed by 5 percentages. And at the same time, the NPV has changed. It's gone from plus 5 to minus 2. It's changed by a total of 7,570. It's gone down from plus 5 to minus 2. Everybody? Pardon? Ekaterina? Did you say no? Oh, I thought you said no. Oh. Alright, and now, but think carefully, now you can write the answer straight down. The internal rate of return, we knew from the start it was more than 10%. Because 10% was plus, we want 0. It must be more than 10. What I need to know is it 1% more, is it 2% more, etc. And it's this bit to make sure you've got, and then it is easy. We know that a change of 7,000 would be 5 percentages. But to get to 0, we only want a change of 5,000. We take a fraction. If 7,000 is 5%, 5,000 is a fraction of it. It's 5/7 of 5%. And then obviously it's just calculator. I get 3.64, somebody check me, but I get 13.64%. Again, look at the choices. Almost certainly the choices would be to 2 places. They may say, what is it to the nearest percent, in which case it's 14. Was that right? Okay.